Starting off with understanding enols and enolates. An enol is a compound that has an alcohol or hydroxyl group that is directly substituted on an alkene, which is a carbon-carbon double bond. An enolate is a resonance-stabilized intermediate of an aldehyde, ester, or ketone that occurs when the alpha carbon of a molecule is deprotonated. Enolates react at the alpha carbon of a molecule. Negative carbon atoms are not stable, therefore they are not favored. Since it does not like the negative charge on the carbon, if there is a partially positive carbonyl carbon nearby, the electrons from the carbon can be resonated toward the partial positive carbonyl. Now the carbonyl carbon will have too many bonds, so the pi electrons between the carbon and oxygen are taken and put as a lone pair on the oxygen atom. The oxygen atom now has 3 lone pairs with a formal charge of -1. The former negative carbon's electrons now form a pi bond between the former carbonyl carbon and former carbanion. This creates the enolate shown. The enolate is a deprotonated enol with a negative oxygen on the same carbon as a carbon-carbon double bond.
All malonic ester synthesis uses this same color pattern and has the same 5 steps. Please come back to this point in the video for future reference.
First, CH3O acts as a base to remove the most acidic proton from the ester, which is on carbon 2 of the mechanism. This forms the enolate. Since enolates are great nucleophiles, it will not act as a nucleophile in an SN2 reaction to attack an alkyl halide, which will form a new carbon bond.
With the addition of a hydronium ion or acidic water, hydrolysis occurs and turns the esters into carboxylic acids. With the addition of heat, decarboxylation happens, and now you have an enol and a carbon dioxide. Since the enol is not stable, it tautomerizes back to a carboxylic acid.
Malonic ester synthesis is a type of reaction where diethylmalonate or another ester of Masonic acid is alkylated at the carbon alpha to both carbonyl groups, then converted to a substituted acetic acid. Diethylmalonate is a volatile diester derivative of malonic acid. It's formed by the replacement of the hydroxyl groups of malonic acid with ethoxy groups. Because of its unique structure, diethylmalonate is highly reactive. Diethylmalonate occurs naturally in fruits such as grapes, strawberries, pineapples, and melon. It's commonly used in fragrances and flavoring to mimic fruity scents. Acetone is also known as acetyl-methylcarbonyl. It's a volatile chiral molecule and is usually a colorless liquid. Acetone has a wide range of uses and is found in cigarettes, foods, cosmetics, and even in detergents. It's widely used in the food and dairy industry as a preservative by a number of fermentative bacteria because it's naturally present in buttery foods such as beer, cheese, and butter, and help give them their characteristic butter-like taste. It's even used in e-cigarettes to help give the liquid a butter or caramel flavor.